Stress is a fundamental survival mechanism. Without stress, we would not fear a lion standing 3 feet away from us. But stress as we know it is the uneasy, anxious, and fatiguing feeling that surfaces when late to a meeting or studying for an exam. Like you, I never considered the processes occurring within us that initiate and respond to stress. Today, we will learn about the neuroscience of stress. Welcome to Jacob's Easy Education. So what is stress? It is the response to deviation in allostasis, which is the maintenance of homeostasis through adaptive change to perceived and anticipated pressures. The response involves a stimulus precipitating a reaction in the brain that activates our fight or flight systems. Stress can be deleterious or beneficial as it pertains to survival. It can be acute, lasting seconds to a few hours, or chronic, lasting several hours per day for a prolonged period of time. What is a stressor? It is any stimulus that elicits a biological stress response. They can be internal or external, physical or psychological, and impinging on consciousness or existing within consciousness, whereby we anticipate threat without existing stimuli. The stress response consists of 2 arms. The first line of response is activation of the sympathetic nervous system. This arm engages fight or flight mechanisms in the body. As we know, the sympathetic nervous system is a function of the autonomic nervous system. A stressor is perceived by the amygdala, which sends action potentials to the brainstem and down the spinal cord and preganglionic axons. At this point, one of 2 things happen. The first is that these action potentials reach the ganglia and are boosted by acetylcholine to postganglionic neurons. Here, norepinephrine neurotransmitters are released by fibers, affecting a response from effector organs. The second thing that occurs is that the action potentials go through a set of nerves that innervate the adrenal glands, which sit on the kidney. Here, they stimulate the adrenal medulla to release epinephrine and norepinephrine hormones, which circulate in the blood. These hormones attach to alpha or beta cells on effector smooth muscles. Alpha receptors contract smooth muscle and beta receptors relax them. Say the smoke alarm sounded in your house. Alpha receptors in the stomach and gut are engaged to inhibit digestive function. Beta receptors in the blood vessel walls are engaged, allowing for increased blood flow to the limbs so that you can act swiftly. The second arm is activation of the hypothalamic pituitary adrenal axis. This is the second line of the response and is slower to engage, but more prolonged in duration. The amygdala sends action potentials to the paraventricular nucleus of the hypothalamus, the PVN. Here, corticotrophin-releasing hormone, CRH, is synthesized. CRH stimulates the anterior pituitary, where corticotrophs synthesize and release ACTH, adrenocorticotropic hormone. This acts on the cortex of the adrenal gland. Here, glucocorticoids are synthesized, the most primary in humans being cortisol. As cortisol is released into the bloodstream, it promotes glycogenesis, lipolysis, and proteolysis, so that we have energy to engage the parasympathetic nervous system and inhibit the SNS first line of response. Cortisol levels in the blood are relayed back to the PVN and are regulated via a negative feedback loop. It must be noted that stress perception varies per individual and is influenced by many factors, including but not limited to stimulus, valence of stimuli, habituation to environment, and sensitization to certain stimuli, as well as early life experience. We develop filtering mechanisms that modulate interpretation of stimuli, subsequently altering our response from the norm. Dysfunction in our stress response occurs with sustained low or high cortisol levels. The former promotes sympathetic nervous system hyperactivity. Overuse of the locus ceruleus, the center of norepinephrine production, heightens defense mechanisms which can, over time, aid development of pathological and neurotic stress-based behavior. For example, insignificant stresses may elicit prolonged and intense, increased heart rate, vasodilation, and racing thoughts. The latter promotes HPA axis hyperactivity, which contributes to depression, anxiety, and bipolar disorder, Cushing syndrome, which involves cognitive impairment, as well as autoimmune disorders, hypothyroidism, and PTSD. Chronic stress triggers noradrenergic neurodegeneration, which is a cause of Parkinson's disease. Increased CRH secretion also inhibits gonadotropin-releasing hormone neurons in the hypothalamus, contributing to impaired reproduction and fertility. Moreover, chronic stress experienced early in life results in permanent endocrine, neural, and immune consequences. The social impact of chronic stress cannot be overlooked either, as it can plague relationships and quality of life. This is why it is important to understand the neuroscience of stress. Statistics on the prevalence of chronic stress in the population are ambiguous, largely due to the difficulty by which stress can be measured and quantified. Cortisol, catecholamine, and ACTH levels can be measured via blood tests. However, this process doesn't model realistic stress episodes when conducted in a clinical setting, and therefore random results are obtained. A future direction for understanding chronic stress may lie in testing stress hormone levels in tailored and controlled scenarios to best map an individual's unique responses to varying stresses. In this concept, pathology would operate in a similar fashion to clinical study, whereby a greater number of variables are accounted for. Currently, we know that peak serum levels of cortisol are found 15 to 20 minutes after HPA axis activation. Measuring SNS arm response is more difficult due to its rapidity. This direction may aid in the treatment of neurological disorders such as schizophrenia, whereby HAP and SNS activity is dysfunctional. So that's all for this video, folks. If you enjoyed the video, like, share and subscribe to Jacob's Easy Education.